Today will do part 3 of lesson 1.4, and it's going to be pages 26 and 27. How are changes in energy and matter related? Do you feel as if you're full of energy today? Energy is the ability to do work or cause change. Every chemical and physical change in matter includes a change in energy. A change as simple as bending a paperclip takes energy. When ice changes to liquid water, it absorbs energy from the surrounding matter. When candle wax burns, it gives off energy as light and heat. Like matter, energy is conserved in a chemical change. Energy is never created or destroyed. It can only be transformed from one form to another. Temperature and thermal energy. Think of how it feels when you walk inside an air-conditioned building from the outdoors on a hot day. Phew, what a difference in temperature. Temperature is a measure of how hot or cold something is. It's related to the energy of motion of the particles of matter. The particles of gas in the warm outside air have greater average energy of motion than the particles of air inside the cool building. Thermal energy is the total energy of the motion of all of the particles in an object. Usually you experience thermal energy when you describe matter as a feeling hot or cold. Temperature and thermal energy are not the same thing, but the amount of thermal energy an object has is related to its temperature. Thermal energy naturally flows from warmer matter to cooler matter. Shade in the arrow that indicates which direction energy will flow between the people and the icy water or the warm mud pit. So here we've got a lady jumping into icy water. Is the energy going to flow from her into the water or from the water into her? Remember, thermal energy naturally flows from warmer matter to cooler. And then the same with this warm mud pit. Is it going to go flow out or flow in? So just remember, energy is the ability to do work or cause change. Every change in matter includes a change in energy. So do all changes in matter absorb energy? No, some changes in matter give off energy. And what happens to energy during a chemical change? Energy is conserved. It is neither created nor destroyed, and it can only be transformed from one form to another. Now, there is a difference between temperature and thermal energy. Temperature is related to the energy of motion of particles in matter. The warmer the particles in matter are, the greater their average energy of motion. Thermal energy is the total energy of all the particles of matter in an object. If you remove a cup of water from the ocean, does the water in the cup have the same temperature as the ocean? Yes, because both have particles moving with the same average energy. Do both have the same thermal energy? Well, no, because the ocean is much larger, so it has more particles, and its total thermal energy is greater. Page 27. Thermal energy and changes in matter. Thermal energy is a form of energy that is often released or absorbed when matter changes. For example, ice absorbs thermal energy from its surrounding when it melts, leaving the surroundings feeling cold. That's why you can pack food and drinks in an ice-filled picnic cooler. Melting of ice is an endothermic change, a change in which energy is absorbed. Changes in matter can also occur when energy is given off. An exothermic change releases energy. Combustion is a chemical change that releases thermal energy and light. Transforming chemical energy. The energy stored in the chemical bonds between atoms is a form of energy called chemical energy. Chemical energy is stored in foods, fuels, and even the cells of your body. Animals like the bear in Figure 7 gain chemical energy from food. Burning fuels transforms chemical energy and releases some of it as thermal energy. When you ride a bike up a hill, chemical energy from your foods you ate changes into energy of motion. Chemical energy can change into other forms of energy, and other forms of energy can change into chemical energy. So we're going to think about endothermic change and exothermic change. When ice melts, is thermal energy released or absorbed? The thermal energy is absorbed. So what kind of change is the melting of ice? That would be an endothermic change. So what is an example of a chemical change in which the thermal energy is released? That would be combustion. And that is an exothermic change. So endothermic change, energy is absorbed. And exothermic change releases energy. So down at the bottom here, you have an analyzing data part. A student records the temperature of 2 reactions once per minute. Her data are plotted on the graph. Calculate what was the change in temperature for each reaction after 10 minutes. On the graph, label each reaction as exothermic or endothermic, and how can you tell? So you're labeling here, and then you're calculating her data. When you're done, you need to upload a picture of this whole part right here. Just this information so I can see how you answered these 2 questions and how you filled in the graph. See you later.